Good morning. I am Kavita, working as assistant professor in Sri Muthukumaran Institute of Technology in the Department of Computer Science and Engineering. Today I am going to present a topic in Introduction to Operating System. The subject code is CS3451. The topic is deadlock. What is deadlock? The deadlock is which is nothing but it is a situation where two or more processes are stuck forever. The main objective of deadlock is to develop a descriptions of deadlock which prevent set of concurrent process from completing the task, and it is to present number of different methods for preventing or avoiding deadlock in a computer systems. The characteristics of deadlock is before going to characteristics, what is deadlock? A deadlock is a situation where two or more processes are stuck forever because each one is waiting for a resource held by the other. No process can move forward. That is called deadlock. And the characteristics of deadlock are there are four conditions to occur deadlock. One is mutual exclusion, hold and wait, no preemption, circular wait. In mutual exclusion, only one process can use a resource at a time. For example, only one person can use one uh, one uh, wa- one pen at a time. That is a mutual exclusion. If there is a only one process uses at a same time, it is called mutual exclusion. Hold and wait. A process holds one resource and wait for another. That is called hold and wait. For example, you are holding your mobile and waiting for a charger. That is hold and wait. And no preemption. No preemption, which is nothing but it is a resource cannot be taken forcefully. For example, you cannot take back a car key by force from someone. That is a no preemption. In circular wait, which is nothing but a circular chain for waiting is exist. For example, a person A waits for B waits for C, and C waits for A. This is called circular wait. Problem. A set of blocked process, each holding a process resource and waiting to acquire resource held by another process in a set. Deadlock cause when a system is freeze, program stop responding, and poor system performance. For example, if a laptop hangs when many apps wait for memory or CPU. That is a deadlock problem. Here, a system has two disk drives. One is the process P1 and P2. Each hold one disk drive, and each needs another one. So this is called deadlock problem. And bridge crossing problem, which is nothing but when traffic only in one direction, each section of a bridge can be viewed as a resource. A car from left enters bridges, a car from right enters bridges. No one can move forward, no one can reverse. This is the situation where a deadlock occurs. Deadlock prevention. In deadlock prevention, make sure at least one deadlock condition never happens. That is to prevent from deadlock. For example, only one direction traffic on a narrow bridges, so deadlock avoided. In operating system, it requests all resource at once. Do not allow circular wait. So allow resource preemption. In mutual exclusion, not required for shareable resource must hold for non-shareable resource. And in hold and wait, must guarantee that whenever your process requests a resource, it does not hold any other resource. And then no preemption. If a process that is holding some resource requests another resource that cannot be immediately allocated to it, then all resources currently being held are released. This is called no preemption. And in circular wait, impose a total ordering of all resource type and require that each process requires resource in an increasing enumeration, that is circular way, to prevent deadlock. And in deadlock avoidance, which is nothing but operating system checks before giving resource whether it is a safe or not. That is to be avoid from a deadlock. It requires that the system has some additional prior information available. For example, a bank checks there is a income and EMI capacity. If loan is risk, it can be rejected. If state means safe means it should be approved for a loan process. And in safe state, what is a safe state? A system is in a safe state if all process can finish execution without deadlock. That is called as safe state. For example, a teacher distributes exam paper only if enough papers are available for everyone. That is called as safe state. Basic facts. If a system is in a safe state, there is no deadlock occur. If a system is in an unsafe state, possibility to for deadlock. If avoidance means avoiding deadlock means ensure that a system will never enter on unsafe state. Here, unsafe state means deadlock occur. If safe state means we can avoid deadlock. Uh, the good example for avoiding this deadlock is Banker's algorithm. Banker's algorithm, which is to avoid a deadlock by checking system safely. Multiple instances, each process must be a prior claim maximum use. So, has for example, a real time example is a banker has limited money, gives loan carefully, and ensures all customers can reply. So similarly, operating system has limited resource allocated carefully and avoid deadlocks. Data structure for bankers algorithm. Operating system maintain available maximum allocation need. In available, if there is a free resource, we can available all the resource. And in maximum only needed to operate a process, and the allocation which is nothing but already given. There is a already given amount. If process can be used the allocated resource and cannot be used more than the allocated resource, and the need remaining for requirement. For example, total pens we have 10 pens. If you give 6 pens, available 4. So likewise we can use only the maximum of resource allocation. If more than the allocation means we cannot access. Safety algorithm, which is nothing but to check whether a system is in safe state or not. In simple idea, we can try to finish a process one by one. If all can finish, it is safe. Else it is not safe. Resource allocation algorithm for P1. If request resource vector for process P1, if request J, okay, then process P1 wants to K instance of a resource type Rj. If request less than or equal to need, then go to step 2. Otherwise, the error condition will occur. If the condition is true, the process will occur. And by when available, we want to find the available means the available should available equal to the formula for available equal to available minus request. So allocation is equal to allocation plus request. So need is need I minus request. If state the resource are allocated to Pi. For example, here Banker's algorithm, there is a 5 process in a state P0 to P4, 3 resources type. A has 10 instance, B has 5 instance, and C has 7 instance. So the snapshot at time T0, allocation here P0 for 010, P1 for 200, P2 for 302, and P3 for 211. The maximum is here mentioned and available is 332. Then how to find need means need equal to maximum minus allocation. So here have to minus the maximum to allocation, then find the need here. So after finding the need, process P1 request. So the process P1 request in the state 102 is less than or equal to available. Yes, the condition is true. So it available the resource. It use the resource and process it uses the available resource and enter to CPU, and it uses the resource and terminate the resource. While completing the task, it will terminate the resource. Deadlock detection. Deadlock detection, which is nothing but it allows system to enter deadlock state in detection algorithm recovery scheme. So how to detect deadlock means, if a deadlock is occur for waiting forever, that is a deadlock is occur. There is a four condition causes deadlock, that is mutual exclusion, hold and wait, circular wait, no preemption. And then how to avoid means check this say the whether the state is safe or not. And then safe state means there is no deadlock. If there is unsafe means there is a deadlock. In Banker's algorithm, smart resource allocation is needed, and detection means find and fix the deadlock. Thank you.